Hello, my dear little champions. Welcome to PW English Medium Class 9th and 10th YouTube channel. My name is Ashok SK. I am your physics teacher. Students, in a Phoenix batch, we had to start a first chapter in a physics. Okay. So in today's session, we are going to start with a first chapter in a physics, that is the motion. Okay. Are you guys excited? If yes, then dive into the topic. Okay. So in today's particular lecture, we are going to start with the first chapter, that is the motion with respect to physics. Okay, so if you see the order of the chapters, so this is going to be a chapter number 7. Okay, and this a Phoenix batch, it is completely dedicated for class 9th students. Okay, so Phoenix batch is completely dedicated for class 9th students and board CBSE, right? So today's subject is the physics and topic is the motion. And my name is Ashok SK and you can call me as AK sir. Okay. And in today's lecture, we are going to start with a very important topic, that is the motion in a straight line. Then after this motion in a straight line, we are going to start with uniform and non-uniform motion. Okay. And after this, uniform and non-uniform motion, very important physical quantities in physics, that is speed and velocity. And the last one, graphical presentation of a motion. Okay, so graphical presentation of motion, how we are going to represent a motion of an object graphically. It is a very interesting topic. Okay, then let's start with the first term, a motion. Okay, so let's try to consider our day-to-day life. We can see many objects, maybe they are moving, okay, or else maybe they are at rest. For example, you can consider a vehicle, okay, they will be moving. Buildings, they are at rest, okay. Your classroom, that is also rest. But a fan rotating in your class, that is in a motion. Air molecules, right? Fish swimming in a water, right? Water flowing. All these example for rest and motion. Okay. Then how can we define this rest and motion in a physics? And we have to see, is there any relationship between this state of rest or motion? Let's see. Okay. So let's try to learn by considering one example. Okay. So if I consider state of the body, okay, not the state of the substance. If I ask you the state of the substance, they'll be saying, sir, solids, liquids, and gases. I am talking about a state of the object or state of the body. Then state of the body, if I consider, okay, state of the body, or else object also you can consider, okay, state of the body. If I consider, you can observe in our day-to-day life, that is the first one, maybe the body is at rest, okay, or maybe the body is in motion. So these are the state of the body. You can see in our day-to-day life, okay, the body may be at rest or maybe in a motion. There is only two states of the body, okay. And in a physics, what exactly this rest means and what exactly this motion means, okay. For example, first we need to try to figure out a point of a reference, or you can say that is a reference point which you are going to consider. Example, let's say one village, okay. So one village, and here there is a one school. Let's consider school. Let's consider a school. Okay, diagrammatically I'm writing this one, okay, building. So let's consider this a school. I'll write a school, okay, your favorite school. In short term, I have written SCL, okay. And let's consider here a railway station, okay. So here there is a one railway station, okay. And if somebody, okay, if somebody is new to the village, if somebody is new to the village and he wanted the location of this school, okay, he wanted location of the school, and there is a one localite. He was standing near the railway station, and this person comes to this localite and asks the address of a school, okay, and how he going to address or say the location of this school? That is the first point. And this person is considering a reference point as a, okay, reference point as this railway station, okay, reference point as a railway station. And with respect to railway station, he says the direction, how direction. If we talk about a direction, okay, so if we talk about a direction, so this is the east, west, north, and south, okay. And let's consider this railway station. It is about here, okay. Let's consider example, okay, railway station, okay, here railway station, and here there is a school, okay, here there is a school according to this, okay. This is the school and this is the railway station, and this person will address the school location as, from railway station, from railway station 2 kilometer due, okay, 2 kilometer due. What is the direction of this from railway station? This is the direction. So you'll say southwest, okay, you'll say southwest. So from railway station, it is the 2 kilometer. Yes, it is a fine. Distance is a 2 kilometer. It is the away from the railway station about a 2 kilometer. But what is the direction with respect to railway station? That is the southwest direction. So here, this fellow localite has considered reference point as a railway station. So this person will get to know the address of the school, okay, or else the location of the school. So simple, we have to know, reference point. A simple thing is that we have to know reference point. So you can ask, sir, instead of this railway station, this localite can consider any other reference point? Yes, it is the depends on, reference point and depends on the observer, okay. So for this case, he is the observer, okay. So he is the observer. With respect to this railway station, the school is a 2 kilometer due southwest. So let's consider one more example, okay. So let's consider this entire, just imagine as our school and our classroom. So here there is a screen, that is a smart board, okay. This is your class. So for me, this screen is a reference point. So this is nothing but I am an observer. Behind me, this is the background. So this background only I am saying it as a reference point, okay. So reference point can be changed, okay. Reference point can be changed, okay. For me, I have considered this background as my reference point, okay. So with respect to this, what is your location? That is nothing but in front of me, okay. So this is how you can decide a reference point. Got it? And let's try to understand the first term, that is the rest, and the second term, a motion, okay. So first thing, let's consider one situation where, okay, so where there is a tree, okay, there is a tree, okay. So here the surrounding or else with respect to time at a t is equals to 0 second, okay, with respect to 0 second, the position of this tree is here, okay. Let's consider the position is x is equals to 0. What is this x is equals to 0? Means that is the reference point. As the time pass, okay, let's consider 1 second, 2 second, 3 second, 4 second, 5 second. Is this tree is changing its position? No. So whenever, okay, here the tree is at rest. The tree is at rest, or else we can say it as a stationary. The tree is at rest or else stationary. On what basis you said this tree is at rest? With respect to this position, okay, with respect to this position, with respect to time, the position of this tree is not changing. Okay, the position of the tree is not changing. So can I consider this tree as an object so that I can define it as very easily? Okay, so if I want to define this rest or else state of rest, I can define this one as the position of the body or an object does not change with respect to, okay, with respect to time. Okay, with respect to time, with respect to reference point. Reference point, let's consider reference point as a screen. Okay, simple thing is that if the object do not change its position, then we can call the state of the object is a rest. Simple. Okay, so let's consider myself. Okay, so with respect to the screen, okay, this respect to screen, so I'm standing. Okay, I'm standing. Let's count the timing. So let's start with a 0 second. Let's have a look. So 1 second, 2 second, 3 second, 4 second, 5 second, and so on. Did I change my position with respect to the screen? No. Let's consider the second case. Okay, so let's consider this is my initial position and the time is 0, and let's count the timing. 1 second, 2 second, 3 second, and 4 second, and 5 second, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here, consider myself as an object, and this object keep on changing its position with respect to time. Then we can say this body is in motion. Getting my point? If the body changes its position with respect to time, with respect to reference point, here reference point is a screen, then we can say this one as a motion of the object. Clear? Okay. So in examination, how to represent this definition of a rest and definition of a motion? When we say the body is in motion, when we say the body is at rest, simple thing. Two statement you remember. If the body or an object changes its position with respect to time, with respect to reference point, then you can say the body is in motion. If the body or an object does not change its position with respect to time, with respect to reference point, you can say the body is at rest. Okay. Now let's move on to the next topic, that is how to represent definitions or concept in your examination, final examination. Okay, so rest and motion. Here I am talking about the rest. Okay, if the position of an object does not changes as the time passes with respect to reference point, it is said to be at rest. Okay, example I have said many example for a rest. Okay, so table, let's consider your classroom, table in your classroom, chair in your classroom outside the building, right? All these are state of rest. All the objects in this examples are in the state of rest. Okay, so here you can consider 1 or 2 examples that is enough to write in your examination. Okay, so table, chair, screen. This screen is also at rest because it is not changing its position. Your classroom do not change its position with respect to time. Then your school and buildings and a tree. Here you can see. So this is the table and all these are chair. These this table as well as the chairs do not change their position, then you can consider it as at rest. And the next one, a screen or else a monitor. This is also at rest. And your classroom or else your home, okay, that is also at rest. And the trees, all the trees at rest. Okay, they do not change their position with respect to time and with respect to reference point. Okay, so let's move on to the next term, that is the motion. Okay, so that is the motion. If the body or else object, okay, if the body or else object, if the position of an object changes as the time passes with respect to reference point, it is said to be in a motion. Okay, so you can consider aeroplane, because it is the keep on its this aeroplane changes its position with respect to time, with respect to reference point. Then you can consider example of this is a vehicle, and this vehicle will be moving. Will be moving means it is keep on changes its position with respect to time and immediate surroundings, or else you can call it as a reference point. And this one, your car, okay, so this car is also moving. That means it is changing its position with respect to time and reference point. Then you can consider this car is in a motion. Then rotating fan. So here you can consider the blades of a fan, okay, not this part, okay, not this part, these blades, okay, the blades of a fan you can consider, those blades are in a motion. Okay, then hands of the clock, they also in a motion. And here raindrops, okay, so raindrops and water will be flowing, okay, water will be flowing. So all these are examples of a rest, right? So is there any relationship between rest and motion? These rest and motion are absolute. Such questions, okay, for such question I'll consider simple example. Okay, what is the relation between this rest and motion? Okay, so here you can see very important point, that is the rest and motion. Okay, the rest and motion are not absolute, but they are relative. What is the meaning of absolute and relative? Okay, so let's try to consider, let's try to understand with the example. Okay, so mass, okay, let's consider a mass. Okay, so let's consider our school classroom. Okay, so I'm your physics teacher. Okay, I bought one bag of mass 2 kg. Okay, 2 kg, one small bag. Okay, so this is a bag of a 2 kg. If I give it to you, okay, if I give it to you, what is the mass of this bag? Still it is a 2 kg. And if you pass this bag of a mass 2 kg to another student or else your friends, what will be the mass of that bag? Still it is a 2 kg. So that means the mass do not change, right? Do not change with respect to observer. It is 2 kg for me and 2 kg for you and 2 kg for your friends also. And if we pass that bag to anybody, okay, the mass of the bag, still it is the 2 kg. That means it is the absolute, no change. Okay, no change in the mass of the bag. Okay, you can consider mass as the absolute quantity. In this case, okay, absolute quantity. And the next one, let's consider a length. Okay, let's try to consider a length. Okay, length. So for example, let's consider the length of the screen is about half a meter, not half meter. Let's consider 1 meter. Okay, 1 meter or 2 meters. So let's overall let's consider a 3 meter only. Okay, this is just for example, 3 meter. Length of the screen smart board, it is the 3 meter. And for me, it is the 3 meter. What about you? If we measure this screen, for you also, it will be a 3 meter only. Okay. And if anybody measures the screen, means the length of the screen, the length of the screen will remain 3 meter only. It do not change. So this is also absolute. Then what about the relative? What about the relative? Okay. So this relative, let's consider a example. Okay. Let's consider example to understand what is this relative. Means rest and motion are a relative. So you and your friend, okay, let's consider physics and math. Okay, physics and maths. So both are friends. Okay, both are friends. Okay, traveling in a car. And here chemistry. Here chemistry. Here a chemistry subject is also traveling. So at a bus stop, let's consider a situation, bus stop. Okay, bus stop. Okay, bus stop. So where physics, chemistry and math, okay, they are meeting at a bus stop. Now both are at rest, this vehicle as well as this vehicle at rest. Okay, at rest. Now let's try to understand. Physics I'll limit as a P, and for a math I'll limit as a M, and chemistry as a C. Okay, so in this particular situation, observer is a chemistry. Okay, observer is chemistry. With respect to chemistry, what is the state of this maths as well as the physics? Maths and physics both are at rest. Okay, both are at rest. Now with respect to observer, okay, now ignore about the chemistry. Now let's concentrate on this particular situation where maths as well as the physics are the observers. Okay, so with respect to maths and physics, chemistry is at rest, right? Chemistry is at rest. Got it? Now what will happen? This car start moving. Okay, has started moving. Now here what happens is, after traveling for some distance, okay, so in this car, physics and mathematics, physics and mathematics are traveling. Okay, mathematics and physics are traveling. Now so this chemistry fellow, okay, this chemistry fellow calls, okay, this chemistry fellow calls to physics fellow, means physics. Okay, calls to physics. He'll receive. Okay, he'll receive. Physics fellow receives the call. Now he'll say, with respect to this chemistry, okay, let's try to understand the second situation. With respect to C, okay, with respect to C means observer is a chemistry. With respect to C, this P and M both are in motion, right? Both are in motion. Now with respect to P, okay, now with respect to C means observer, both P as well as M, physics as well as maths are in motion. Okay, now ignore this situation, let's concentrate on this. Okay, with respect to physics and maths, okay, observer, physics and maths. Okay, now with respect to physics, what is the state of the maths? So as maths is beside him, okay, he'll be traveling along with him. With respect to this car, what is the state of this math? At rest. And what about the chemistry? Chemistry moving backward with respect to this car, right? With respect to car, this car is moving backward, but in reality the car is still at rest only. It is still at rest only, but as per this car, it looks like the car is moving backward. Okay, in reality this car is moving forward, but appears this car is moving backward. Okay, so that means with respect to P, the C is in motion. Chemistry is in motion. Okay. And with respect to M, at the same time, with respect to M, means now observer is a maths. What is the state of this physics? Physics at rest. Okay. Physics at rest. And what about the chemistry? Chemistry is in motion. Chemistry is in motion. See, at the same time, when observer is a chemistry, both maths as well as the physics are in motion. When at the same time, when a physics is the observer, maths is at rest, but a chemistry is in motion. At the same time, when observer is the mathematics or else maths, physics is at rest, but chemistry is in motion. Okay, at the same time, different observations. Now, will you say this rest and motion are absolute? No, they are not absolute. It depends on observer. Observer means who is making observation. So in this particular case, everything is at rest. But in this case, situation is changing. Physics and mathematics in motion. But here, maths is rest, right? With respect to chemistry, both are in motion. But with respect to physics, maths is rest and chemistry is in motion. But with respect to maths, physics is rest and maths is in motion. Okay? So we can conclude that, this rest and motion are not absolute. They are relative. Got it? So this is very important point. Okay, this is very important point. Right? Now, so here you can see best example for, rest and motion are relative. Best example for rest and motion are relative. Okay. So you are traveling in a bus. Okay. You are traveling in a bus. So when you see inside the bus, everybody in the bus are in the state of rest. But when you look out of the window, outside, okay, everything appears to be moving backward. Okay. But in the reality, these trees as well as buildings are in the state of rest only, but your bus is moving. But according to you, you are the observer. So for you, it appears inside the bus, everything is at rest, but outside the bus, everything is moving. At the same time, you see, at the same time, it is at rest and it is moving. So we cannot say this rest is absolute or motion is absolute, but it depends on observer. So this rest and motion are relative terms. Okay, hopefully this point is clear for everybody. Okay, right. So let's move on to the next topic, that is the distance. So what do I mean by this distance? Okay, so for this also I'll consider example. Okay, right, let's consider example. This is the path. Okay, this dotted line indicates a path. Yes, here one body is there, means let's consider a student A. Okay, student A. So at a t is equals to 0 second, means at a t is equals to 0 second, means starting, the position of this object is 0 meter. Okay, and as the time changes, this body keep on changes its position. For example, student A at a t is equals to 0 second, the same students will be moving or else changing his position. Okay, in t is equals to 1 second, and distance is x is equals to, here I'll write x is equals to 1 meter. Okay, and the same students at a t is equals to 3 seconds. Okay, 3 is equals to 3 seconds, and here the same student, the position of this student is a 2 meter, and it will keep on continue. So here you can see the student A initially x is equals to 0 means it is the initial position. Okay, initial position, or else you can consider a starting point. Okay, starting point at a t is equals to 0, here starting point is 0. After 1 second, the student has traveled 1 meter. After 2 seconds, okay, this is 2 seconds, this must be 2 seconds. Okay, 2 seconds, the student has traveled 2 meter, and here you can say, as the body or student changing his position with respect to time. You see 0, 0, 1 second 1 meter, 2 second 2 meter. That means the body is changing its position with respect to time. That means the student is in motion. Okay, the student is in motion, right? The student is in motion. Okay, and here my question is, these are the position. Okay, x is equals to 0, x is equals to 0 meter, x is equals to 1 meter, x is equals to 2 meter. All these are position of the object. Okay, if I keep on adding the positions, okay, this is the first position, this is the second position, and this is the third position. If I join all these points, okay, if I join all these points from here to here, okay, here to here, then the successive line joining of the position, we call it as a length. Okay, length. So length, or else you can call it as a path length. Okay, path length. In this particular situation, what is the path length? Or else the length of the path traveled by the student A. Here you can see from here to here 1 meter, from here to here 1 meter. Total from the reference point or else starting point, the student A has traveled 2 meter. Then this 2 meter we are calling it as a distance. Okay, and second situation, let's try to understand. Okay, in a 2 seconds, right? This is in a 2 seconds. In 2 seconds, the same student, okay, the same students. Let's consider same students in another case. Okay, here also student A only. Student A. Student A. So initial position x is equals to 0 meter and t is equals to 0 second. This is 0 meter. Okay, and from here, okay, from here the student has traveled. The student has traveled 5 meter. Okay, x is equals to 5 meter. Okay, and here let's consider t is equals to 3 seconds. Okay, 3 seconds. In 3 seconds, the student has traveled 5 meter. And then the student has reached this point. That point is 9 meter. And the time taken to reach this position, let's consider 5 seconds. As the time changing, the position of the student is keep on changing. That means the body is in a motion. Okay, and let's consider this is the point, this student A, right? So P, and this is a Q, and this is R, PQR. So what is the length traveled by the student A? This is student A, and this is also student A. So here you can consider total length. Let's consider total length. Instead of length, let's consider total length traveled by the student. Okay, so P to Q, from here to here, then Q to R, from here to here, that is the QR. What if the student has returned to his original position? Okay, if the student has reached in a original position in a t is equals to 10 seconds. Okay, so then R to P, final R to P. Here you can see the student has started his journey at a t is equals to 0 from point P and reached Q. That means P to Q, then Q to R, then R to directly P point. Okay, R to P. Then what is the total length this student has traveled? So here you can see P to Q. P to Q, what is the distance from here to here? So 5 meter. And from here to here, so here, what is the distance? 5 and 9. What is the difference? 9 minus 5, that is the 4 meter. So that means 5 meter plus 4 meter, and R to P point, that is total distance 4 plus 5, that is the 9 meter. So what is the total? 9 plus 9, that is the 18 meter. Okay, so this total length, okay, this total length, we call it as a distance. Here the body has changed its direction. Initially the body is moving in this direction, right? That is along plus x-axis coordinate system. Okay, now if you consider after reaching point R, the body has changed its direction and moving in opposite direction. But here we have not considered a direction of the body. Just we are adding the length of the body traveled, right? So here length of the path traveled by the body is 18 meter. So this one we are calling it as a distance. Okay, distance. Here you can see generally length is measured by, okay, length is measured by meter rule or else your scale, right? So these are the measuring instrument of a length. But what is the SI unit of a length? Here SI unit of a length means SI, system internationally accepted unit. That is a meter. Length is always measured in a meter. That is in a SI system. Okay, SI system, the length is measured in a meter. And it is represented by small letter m. Got it? Right. So how to represent this distance in examination? Here you can see distance. Definition. The total length of the path covered by the object is the distance. Okay. So simple. Total length of the path covered by the object is called a distance. And it does not depend on a direction. Okay. It does not depend on a direction. So here you can consider SI unit is meter. Okay, SI unit is a meter and it is represented by small letter m, not capital letter M. And the quantity, here quantity divided into two type based on their direction and magnitude. Okay, so one is a scalar and another one is a vector. Okay, so small introduction for a quantity. Okay, small introduction for a quantity. For 9th grade, it is not required, but just I'm giving introduction. Okay, so quantity is the divided into two parts. Okay, scalar, the next one vector. Okay, and this scalar does not depend on, or else not depend on direction, not depend on direction, not depend on direction. And but this vector depends on direction. Depends on direction. Simple. Okay. As we have seen, the distance is not depends on a direction. Therefore, which type of a quantity, scalar or vector? So here you can write this as a scalar. Okay. And example here you can consider, here there is a straight road. If the the body, if I consider, okay, let's consider t is equals to 0 second and initial position it is a 0, that means a starting point, and has traveled, let's consider it as a 100 meter. Okay, 100 meter, this is the 100 meter. Then what is the distance? What is the distance of this body has traveled? Distance is nothing but total length of the path covered. Therefore, the distance is nothing but 100 meter in this particular situation. Okay, so in this case, distance is 100 meter. Okay, then in this case, let's consider path, length of the path from here to here, it is a 2 kilometer. Okay, 2 kilometer. Let's consider 2 kilometer. The body has started its journey from here at a t is equals to 0 second, and till here the total length of the path, it is a 2 kilometer. Therefore, what is the distance in this particular situation? Okay, so that distance is a 2 kilometers. Got it? Okay, so this is about distance. You'll be having one question. Okay, sir, what if we consider a direction? What if we only consider initial and final position of the object? And what if we do not consider the shape of the length traveled by the object? What if we don't consider total length of the path covered by the object? Then we have a new physical quantity, that is the displacement. Okay, so let's try to understand what is this displacement. Okay, and for this I'll consider simple example. Okay, simple example. So this is the initial point. Okay, this is the initial point, t is equals to 0 second. Okay, ignore about time. Okay, we understood if the body is changing its position with respect to time, then we can call it as the body is in motion. Now, so this is the initial position. Let's consider the position is x is equals to 0 meter. Okay. And finally, the body is here. After traveling, x is equals to 10 meter. Okay. So that means the total length of the path covered by the object or body, that is the 10 meter. This is the length, the total length of the body. So what is the distance? What is the distance? Distance is 10 meters, sir. Okay. Then distance is does not depends on a direction. Ignore it. What if we consider a direction? That means initial and final position. This is the initial position. Okay. This is initial position and this is a final position. Okay. This is the final position. So here the total length, instead of considering total length, what if I consider final position and initial position only? So the distance between, okay, it is all displacement is also distance only. Okay. But here condition is the distance between initial and final position. So here initial position, it is a 0 meter and final position, this is also 10 meter. And what is the direction? Direction, if I consider, this is towards east. Okay. So if I consider displacement, okay, displacement is nothing but final position minus, okay, so final position minus initial position. Okay. Final position minus initial position. What is the final position? Here let's consider this is the 10 meter and initial position, that is the 0 meter. Therefore it is the 10 meter. Got it? So here displacement, okay, here displacement is 10 meter. But here we are considering direction also. Therefore displacement 10 meter due east, right? So this is the one way of expressing displacement and distance. Okay. Let's consider one more example. Okay. Let's consider one more example. So this is the path. Okay. This is the path. And the body, consider x is equals to 0 meter. Okay. X is equals to 0 meter. And this is the body. So the body has traveled a distance. Okay. A distance x is equals to 10 meter. Okay. So let's consider this is the A point and this is the B point. This is the A point and this is the B point. Now, the body has traveled half of the distance. Okay. This is a point C. Means the body has traveled, okay. The body has traveled A to B, then C. Okay. Let's consider from x is equals to 0 meter to x is equals to 10 meter. Then what is the total length? Total length. Why do we need to consider total length? Because the distance is given by total length of the path covered by the object, or else the total path length covered by the object is called a distance. So A to B, that is a A to B, then plus B to C. So here A to B, it is a 10 meter and B to C, it is a half. Okay, so it is the half of the distance, that is 5 meter. Okay, so from here to here 5 meters, so 5. So total distance, it is the 15 meter. 10 plus 5, 15 meter. So this one we call it as a distance. Okay, we call it as a distance. Now, what is the displacement? According to the definition, it is the shortest distance between final position and initial position. Okay, so here displacement, if I consider, okay, shortest distance between final position and initial position. Let's consider FP, final position, IP, initial position. Okay, so what is the final position here? This one, final position, and this one, initial position. Okay, so according to the definition, final position is a C and initial position is A. Okay, so here a C position, it is a 5 meter, right? This is the 5 meter, x is equals to 5 meter. So 5 minus initial position is how much? That is the 0. So that means 5 meter. Then what is the direction of the body? Now at a point C, this is the direction. That is the towards west. Towards west. Okay. So here you can see distance and displacement. Okay. Distance is 15 meter, but displacement is just 5 meter. What does it indicate? What does it indicate? So here there is no significance of a direction. Here we can see the direction. Okay, this is a due west. This is a due west. What is the direction? Means due west. Okay, so distance is a 15 meter, displacement is a 5 meter. There is a one important condition. Displacement cannot be more than or cannot be greater than a distance, but it can be equal or less than a distance. Cannot be more than distance. That is the significance. Okay. Then as we are measuring a distance between final position and initial position, then what is the SI unit of a distance? Still it is the meter. Therefore, displacement unit is also meter. So for that, let's try to define a displacement. Okay. So definition. The shortest distance measured from initial to the final position of an object is known as the displacement. Okay. And SI unit, okay, in this case SI unit, still it is a meter and represented by small letter m. And displacement, we are considering direction also. Therefore, it is a vector. It is a vector because it depends on a direction. You see, the shortest distance measured from initial to the final position. Initial to the final position. How much? Initial to the final position. 5 meter. And what is the direction of a body at a point C? That is the from final position. So this is the initial direction. Okay, this is the initial direction. And here at a final position, it is the opposite direction. Okay. So opposite direction means initially it is the west, finally it is initially it is a east direction, finally it is a west direction. Due west. Okay, right. So let's move on to the next concept. That is a motion in a straight line. Okay. So the body can move in any direction, right? Any direction, any path. So it can move in any shape of the path length. For example, if I consider the body has started from here, okay? This is the starting point of the body. It can move straight from here to here. Or else, this body can move like this, right? Or else, this body can move like this. There is a possibility. But for our syllabus, here we have only one type of a motion, that is a straight line motion. Means the direction is fixed. Okay, direction is fixed and the path is also fixed. Means a straight path. So here if I want to present a motion in a straight line, what is the path of the body? Path length of the body. So it is a straight line. So let's consider the body has started from here and finally the body is at here. Okay. So if I consider this is the A point and this is the B point and finally the body is at here. Okay, at a point C. Means the body initially has started from here. This is the direction. Initial direction is east direction, right? This is the east direction and has reached B point and coming back to the original position. And finally, the body position is here and the final position of the body and the direction in this way. Okay, and this direction is a west. Okay, this direction is a west. Now here, if I want to express the distance, how do you express? Already we got to know what is the distance and displacement. Distance is nothing but total length of the path. Let's consider total length. So example, if I consider this is the 3 meter, okay, from here to here, if I consider 3 meter, okay. So A to B. So let's consider this is the 7 meter. Okay, from here to here. So total distance, that is the A to B plus B to C. So what is the distance from A to B? This is the 3 meter and this is the 7 meter. 3 plus 7, that is the 10 meter. Okay. And also here, one more thing you need to add, okay. The body has started from A, reached point B, okay. A to B and B to C. So that means here AB, what is the distance? A to B, that is the 3 plus 7 meter plus B to C. What is the length? That is the 7. So 3 plus 7, that is the 10. 10 plus 7, that is the 17 meter. Okay. So this is our distance. So this is our distance. This is our distance. Okay. And what about the displacement? Displacement. Can you guess? Displacement. And it is the distance measured from initial to final. Okay, initial to final. And you just specify the direction. Initial to final. This is the initial position. This is the final position. What is the distance between them? 3 meter. But what is the direction? Due west. Due west. So this is how you can calculate the distance and the displacement of the object. Got it? Easy, right? Now, let's move on to the next concept, that is the uniform motion and non-uniform motion. So motion means, already we know that the change of the position of an object with respect to time and a reference point, right? So we call it as a, motion of the body. If the body do not change its position, then we call the body is at rest. Simple. Now, if the body is in moving, okay, or else the body is in motion, then the body can move faster or slower or else a different direction, right? So here, as our concept is a motion in a straight line, so let's consider two examples, okay? Let's consider two examples. This is the road, okay? This is the road. This is the road. And here let's consider x is equals to 0 kilometer. And this is the 10 kilometers. And this is the 20 kilometers. And this is the 30 kilometers. And this is 40 kilometers. And this is the 50 kilometers. This is 50 kilometers, okay? And here there is a one vehicle. There is a one vehicle. There is a one vehicle. Okay. And the body or else this vehicle is moving in this direction. Okay. And it is in a motion. It is in a motion. But we need to know what type of a motion. Okay. Based on it covers the distance with respect to time. Now, in 1 hour, okay, in 1 hour, the distance traveled by this car is 10 kilometer. In the second hour, okay, second hour means from here to here 1 hour. Again, it has covered 20 kilometer. And third hour means from 2 hours to 3 hours, 1 hour. In 1 hour, again 10 kilometers. And fourth hour, okay, fourth hour, again it has covered 10 kilometer. And fifth hour, again it is covered 10 kilometer. Sir, but here 20, 30, 40, 50 kilometer they have given. But you are saying 10 kilometer, 10 kilometer, 10 kilometer. Don't concentrate on 20 kilometer, 30 kilometer, 40 kilometer. So from one position to other position, how much distance this car has traveled and how much time it has taken. That we need to concentrate, okay? Now, here you can see from 0 kilometer, that means it is a 0 hour. Okay, it is the from rest or else starting point, okay? So in 1 hour, what is the distance traveled? 10 minus 0, it is the 10. So that means 10 kilometers. Okay. And from 1 hour to 2 hour means what is the time taken from here to here? 1 hour from here to here. And what is the distance traveled? So 10 kilometer, 20 kilometer. What is the difference? That is the 10 kilometer only. Okay. Then 2 hours to 3 hours. What is the time taken? 1 hour. So 2 hour to 3 hour, 1 hour only, right? What is the distance traveled? It is also 10 kilometers. And here also 1 hour and 10 kilometers. 1 hour and 10 kilometers. From here to here, 1 hour, 10 kilometers. Clear? 10 kilometers. Okay, so 10 kilometers. So you can observe in equal interval of a time, okay? So from here to here, it is the 1 hour only, right? This is 1 hour. So from here to here, time taken by the body 1 hour, and distance traveled by it is a 10 kilometer. And here, time taken by the car 1 hour, and distance traveled 10 kilometer. 1 hour 10 kilometer, 1 hour 10 kilometer, 1 hour 10 kilometer. So if the body covers equal distances in an equal interval of time, then we can call the motion is uniform. Uniform means the same. At every interval, you can see, at every point, you can see the time taken is same and distance is covered. Okay, distance covered is also same. In 1 hour, 10 kilometer, 1 hour, 10 kilometer, 1 hour, 10 kilometer. Means equal interval of time, equal interval of, equal distances in an equal interval of time. Then you can say this car is moving with a uniform motion. And in the same direction is also matter. Okay, so if there is a change in direction, then it is not a uniform motion. Okay, it is not a uniform motion, even though if it is covering equal distance in equal interval of a time. But if direction changes, non-uniform. Getting your point? So simple and easiest way to understand this uniform and non-uniform motion, it is the distance and time. Okay, if an object covers equal distances in an equal time intervals, it is said to move with a uniform motion. I hope it is clear for you. Okay, and you can say, sir, in our day-to-day life, it is not possible. It is not possible. For example, let's consider one city. Okay, city you consider, or else you can consider your city only. Okay, so example, let's take your bike, home bike, or else car. So you'll be traveling from home to your school. Okay, so while traveling from home to school, you can see motion of your vehicle. Maybe it is a bike or maybe it is the car. So initially it will be at rest. After starting, it will change its position. That means it is then a motion. But do you think your vehicle will cover equal distances in equal interval of time? Not possible. Why? Maybe due to traffic signal, maybe due to traffic, maybe due to humps, right? Maybe due to crowded place. Our vehicle cannot cover equal distances in an equal interval of time. That means in our day-to-day life, the motion of vehicles not uniform. Instead of that, you can say it is a non-uniform, because these bodies or these vehicles cannot cover equal distances in equal interval of time throughout the day, right? Correct. So that kind of motion we can consider non-uniform motion. Simple. Okay, now non-uniform motion. If an object does not cover equal distances in equal interval of time intervals, it is said to move with a uniform motion. Example, sir, example, let's consider again one road. Okay, one road and our vehicle. Let's consider one vehicle. Yes, and tires, and it is moving. Okay, moving towards x axis, or else you can say along the positive x axis. Motion, it is in motion. Okay, so initially at t is equals to 0 and x is equals to 0. Okay, now after 1 hour, okay, it has covered 10 kilometers. Okay, and after 1 hour, that means 2 hours, it has covered 25 kilometers. After 1 hour, that is third hour, that is a 30 kilometer. And fourth hour, and the distance is 60 kilometers. And fifth hour, okay, fifth hour, distance is 62 kilometer. So here you can see time interval. Let's check out the time interval from 0 to 1. This is the 1 hour. And distance traveled 10 kilometer. Yes, fine. So from here to here, 1 hour, 10 kilometer. And from here to here, time interval, it is the 1 hour. And a distance traveled 15 kilometer. Okay. And time interval 2 and 3, that is a 1 hour time interval, and from here to here 5 kilometer. Okay, and from 3 to 4th hour, that is the time interval, that is the 1 hour, and distance traveled 30 kilometer. Okay, 30 kilometer. And from 4th hour to 5th hour, that is the time interval 1 hour again, 60 kilometer and 62 kilometer. Distance traveled, that is the 2 kilometer. Let's check out in an equal interval of a time. Okay, 1 hour, 1 hour, 1 hour, 1 hour, and 1 hour. Time is equal. Time interval is equal. But distance, you see, first interval 10 kilometer. Second interval, that is the 15 kilometer. Third interval 5 kilometer. And the fourth interval, that is the 30 kilometer. And the fifth interval, that is the just a 2 kilometer. That means this car is moving with a non-uniform, because this car is not covering equal distances in a equal interval of it. Right? If the body do not cover equal distances in an equal interval of a time, then we can say that the body is moving with a non-uniform motion. Got it? So in our day-to-day life, we experience non-uniform motion only. Right? So let's move on to the next concept. That is the measuring rate of motion. So just now we have seen, uniform motion as well as non-uniform motion. Here, how do you measure rate of a motion? How do you measure rate of motion? Means which one is moving faster, which one is moving slower. Here we have two terms. That is, one, it is the speed, or else velocity. And there is some parameters, okay? There are some parameters which is related to motion, okay? Parameters which is related to motion. What are those parameters? The first one, okay, it is the distance. Already we have discussed. Means it is the total length of the path covered by the object, okay, or else the total length of the path covered by the object. And the second one, that is the displacement. And this displacement is nothing but it is the shortest distance between initial and final position of the body, or else an object. Okay. And what is the difference between this distance and displacement? Still here also we are defining distance. Then what is the difference between these two? This is total length, but here shortest length between initial and final position. This is a scalar quantity, whereas the displacement, it is the vector quantity. Okay, these are two parameters related to motion. And the measuring of rate of change of a motion. Okay, rate of motion. Rate means with respect to time. Okay, rate means with respect to time. So here, rate of a motion, we can use two terms, that is the speed as well as a velocity. Okay, speed as well as velocity. Speed or velocity. And the last one, that is the acceleration. So these are the parameters related to a motion. Okay, and rate of motion, how do you measure? Means that is using speed or velocity of the body. Then let's try to understand speed and velocity. Okay, the first one, speed. Speed means, okay, speed means, let's try to understand with an example, better example. Okay, so let's consider car and bike. Okay, car and bike. So destination is same. Let's say 100 kilometer. Okay, 100 kilometer. The initial position and the final position, it is 100 kilometer only. 100 kilometer. One body, it is the car. Another body, it is the bike. And at the same time, t is equals to 0 second. Okay, t is equals to 0 hour. Let's consider hour only. 0 hour. That means a 0 second. Means the time at a 0, the distance is also 0. After some time, okay, after some time, these two bodies, both the car as well as the bike, has reached that 100 kilometer. Okay, what is the distance traveled by these two bodies? That is the total length of the path, that is 100 kilometer. The distance covered by the car is also 100 kilometer, and distance traveled by the bike is also 100 kilometer. Okay, But here condition is, and a very important point that need to be take care, that is the time. Which one has reached faster, or else which vehicle or which body has reached earlier. That means which body has taken less time to reach the destination, that is 100 kilometer. So let's consider the car has taken less time compared to the bike. Then what does that mean? That means the speed of this objects. One is a car as well as the second one a bike. Okay. So in this particular situation, we can say that speed is nothing but how fast the body is moving. That means with respect to time. How fast the body is moving. Here we have considered example of a car as well as a bike. In this particular situation, we can say that the car is moving faster than bike because the car has reached earlier than the bike, right? To reach 100 kilometers, that car has taken less time. So that means to define the speed, okay, or else to define how fast the body is moving, we required two parameters. That is one, distance. The second one is the time. So to define this speed, we need two parameters. The first one a distance, second one is a time. Okay. So by that aram say we can define it. Okay. So speed is nothing but a rate of change of a distance, or else the distance traveled by the body divided by time taken. What is the distance traveled by the body and what is the time taken by the body? That gives you the speed of the body. Example, let's try to consider example. Okay, in the two cases, four cases I'll consider. Okay, four cases I'll consider. Yes. So let's consider body, and this is one more body, and this is one more body, and this is one more body. Okay, let's consider A, B, C, and D. So total distance, let's say it is 100 kilometer, and it is also 100 kilometer. Okay, and this one is 50 kilometer, and this is also 50 kilometer. Okay, 50 kilometer and 50 kilometer. So in this case, in this particular case, the body has started its journey, both the bodies A and B. Okay, so in A and B, the body A has reached in T is equals to, let's say, 5 hours, and the body B has reached this 100 kilometer just by 4 hours. Okay, what is the speed between these two objects or else these two bodies? Okay, distance is same and the time it is the 5 hour and this is the 4 hour. Which one has reached faster? That is the point body B. How to calculate the speed of the body? It is the easiest way, that the speed is nothing but the distance divided by time taken. Distance means 100 kilometer divided by time taken, that is a 4. Okay, so you can see 4 to the 8 and 2 carry and 5. Okay, so 25 kilometer per hour. And what about this? Distance is 100 kilometer only, but the time taken it is a 5. So that means 5 to the 10 and followed by 20. That means 20 kilometer per hour. So which one is moving faster? The body B. Simple. Okay. Now second one. So the body C has reached 50 kilometer. Okay. So 50 kilometer in 5 hours. Okay. In 5 hours. Okay. And this one, let's consider this is 100 kilometer. Okay. Example purpose. This is 100 kilometer. And it is also 5 hours. In the first case, you can see the distance is same. 100 kilometer, 100 kilometer. But the time is different. Okay. Time is different. So in this particular situation, if a time is less, the speed of the body is more when the distance is same. In this particular situation, you see time is same, right? 5 hours, but distance is different, 50 kilometer and 100 kilometer. Which one is moving faster? Let's try to understand. So it reached 50 kilometer in 5 hours, but in the same time, the body D has reached 100 kilometer. Which one is faster? This body D. Sir, how? See, in the same time, meantime, that is a 50 kilometer. The body C has traveled, but in the same time, the body D has traveled 100 kilometer. That means which one is faster? That body D. How to calculate it? Again, same method. What is that method? What is that method, sir? So same distance is 50 kilometer and the time is of 5. That means a 10 kilometer per hour. Okay, so 10 kilometer per hour. In the second example, you consider 100 kilometer and time taken 5. So that means, so 2 and 0, 20 kilometer per hour. So this is faster, right? So finally, you can say that the speed of the body is indicating how fast the body is moving, right? And it is directly proportional to the distance and inversely proportional to the time taken in the journey. Okay, so let's define this term. What is that term? That is the speed. Definition of the speed. The speed of an object is equal to the distance traveled by the object divided by time interval. So formula, if you want me to write that a speed is equals to distance traveled, okay? Distance traveled divided by time taken in entire journey, okay? So this is the formula. And unit, if you want to know, just you see speed, unit of a speed, that equals to unit of a distance divided by unit of a time. So in this particular situation, unit of a speed, okay, unit of a speed, that equals to, according to the formula, unit of a distance, I'll write it short, and unit of a time. Unit of time. And we know that, okay, unit of a distance is the meter. Unit of a distance is a meter. Why? Distance is nothing but a length. So meter, and the unit of a time, that is a second. Okay, second. Therefore, you can write in a short form, meter per second. Okay. And the quantity does not depends on a direction. Why? Because distance is a scalar and time is also scalar. Therefore, the speed is also scalar. Okay. Because we have not considered any direction, right? Just we are showing the motion of the body, but we have not specified the direction. Getting my point? Okay. Now, average speed means for a non-uniform motion. For a non-uniform motion means sometime it is covering, some equal distance. After some time it covers unequal distance. In entire journey, the distance covered by the body will not be same. So that is the reason what we need to do. So let's consider average speed. Means from the one point to the end point. What is the average speed? Clubbing all the speeds. How to calculate it? Total distance traveled by the body divided by total time in entire journey. Simple. Okay. That is in terms of a non-uniform motion. Uniform motion, for example, you can consider this, because equal distance in equal interval of time, directly go for this formula. Okay. What is that formula? This one. But when you consider non-uniform motion, you have to consider, okay, non-uniform motion. For a non-uniform motion, you have to consider total distance. Total distance divided by total time. Okay, total time. This is the average speed formula. Okay, average speed formula. Let's move on to the next topic. Before that, you'll be having one small question, right? Sir, here we have not, decided or specified the direction. What happens if we decide or specified the direction? Okay. So here, the complete information means the magnitude as well as the direction. If we specified, then the speed along with the direction. Okay. Speed with the direction. What is the quantity? That a new quantity is called a velocity. Velocity is also speed, but along with the direction, we are going to specify it. Simple. Okay. So let's start with Yeah, before that, here we have a small question. Okay, so let's try to solve this question. Okay, easiest question. So the question says an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed? Concentrate the word. Okay, concentrate on the words. Okay, average speed of the object. So here we need to calculate not just a speed. Instead of a speed, we need to calculate average speed. Why need to calculate average speed? Here you can observe that an object travels 16 meter in a 4 second. Then the same 16 meter in 2 second means it covers equal distance but not in equal interval of a time. Or else equal interval of a time. In a equal interval of a time, the body is not covering equal distances. Then the motion is a non-uniform motion. Okay. This motion is non-uniform. The motion is non-uniform. Okay, non-uniform motion. Let's try to understand the given question. Okay, so to solve numerical problems in our physics, okay, so first you need to follow the systematic procedure so that you will get total marks given to that particular question, numerical problems. Okay, to get a full marks in a numerical problems, you need to follow systematic procedure. What is that a systematic procedure? Let's check out. The first, you need to write down given data. First, you need to write down given data. What is that data? So data is the first, you see, what is the distance? The first distance, okay, distance 1. How much total distance? Total distance first we have to write, okay, total distance. Total distance. Total distance. Total distance traveled. Okay, total distance. Here 16 meter. Okay, sir, 16 meter. Plus here 16 meter. Yes, sir, 16 meter. Total, it is the 32 meters, right? 32 meters. And what is the total time taken? Total time. Total time, sir, here 4 seconds and here 2 seconds. That is 4 seconds plus 2 seconds. That is a 6 second. Got it? Okay. Now, what is the relation between total distance and total time? That is average speed. That's what they are asking. That is the average speed. So for that average speed, that is given by total distance traveled divided by total time taken by the body or object in entire journey. Now, what do we have to do? After substituting the formula, you need to substitute the values or data in the given formula. What is the total distance? That is 32 meters. And total time, that is the 6 seconds. Okay. And try to solve this question using calculator, or else if you know if you are good at maths, you can go ahead. Okay. So that is 32 divided by 6 seconds. That is 5 point. Okay. So 5.33. Okay. 2 digits enough. 5.333 and so on. This 2 digits enough after decimal point. Okay. Or else we can round it off. Okay. 5.34 and meter. If we consider this a second in the denominator, if we bring it to the numerator, what happens? Per second. If it is considered 1. If we bring this s power 1 to the numerator, it becomes a minus. If it is a minus, if we bring to the numerator, it becomes a plus. Opposite sign. Okay. You can write this one as 5.34 meter per second. Okay. So that's all for this question. Okay. So they have asked average speed. We found out average speed. That is a 5.34 meter per second. Okay. 5.34 meter per second. Right. Now, let's move on to the next concept, that is the velocity. As I said, this velocity is nothing but speed only. Velocity is nothing but a speed only, but along with the direction. So that we call it as a velocity. Okay. The velocity, definition wise, okay, by the definition, the velocity of an object is a quantity that gives the speed of the object as well as its direction. Means magnitude, that is the speed of the object, then direction. So when we specify a direction, the quantity becomes a vector quantity. Or else the vector quantities can be represented by or expressed by both magnitude and direction. Getting my point? Okay. Now, so this is the simplest definition of velocity. Or else if you want even simplest definition, you can go ahead with the rate of change of a displacement. Or else displacement divided by time taken by the body. Simplest definition, displacement divided by time taken by the body in the journey. That's all. Okay. And a second most simplest definition, that is the velocity of an object is equal to the displacement of an object divided by time interval. Okay. Now, what is the SI unit? As we have a defined speed, as well as we know SI unit of a speed, and we know what type of a quantity the speed is, right? So definition wise, it is the distance divided by time, and SI unit, it is a meter per second. Already we know that how to derive that meter per second, right? This is how we derive that meter per second. And quantity, that is a scalar, because it does not depends on a direction, but velocity, it depends on a direction, hence it is a vector quantity. Okay. Now formula wise, okay, formula wise, velocity that equals to, okay, so words only I'll write, velocity that equals to displacement divided by time. Simple. Okay. Or else you can write V equals to short form, okay, displacement divided by time. This is also you can express the formula. Okay, this is the formula. Then what is the SI unit? Simple, same, meter per second. Symbolically, how do you write? Meter per second. Okay, and the quantity, as it is depends on a direction, you can write it as a scalar. Instead of a scalar, you can write a vector, as it depends on a direction, magnitude and direction. And the last one, average velocity. Average velocity, when you consider, when velocity is a variable, okay, velocity is variable means it changes when velocity changes. So in a uniform motion, velocity remains same at every interval of a time, at every position. Okay, so motion of the body remains the same. But when you consider non-uniform motion, means it the body do not covers equal distance in equal interval of time. Also, the direction can be changed. In that particular situation, we can say when the distance is not covered in equal interval of a time, or else if the body changes its direction, then you can call the change in a velocity, even though if it is the covering equal distances in equal interval of time, because velocity depends on direction as well. Okay. Now, based on that, here you can consider initial velocity. Here write initial velocity in, final velocity divided by total time. Okay, so here I'll write a full words, don't go for shortcut method, so I'll write a full terms. Okay, right. So initial velocity plus final velocity divided by total time. Okay, so this is average velocity. This is for non-uniform velocity. Okay, that means initial velocity of the body is different and final velocity of the body is different. Then you can call it as a variable or else non-uniform motion. What if the velocity is same at every interval of a time? Then you can call it as a uniform motion. But this one, it is for a non-uniform motion. Okay, now let's move on to the next one. That is the example, means a numerical question. 7.2. The odometer of a car reads 2000 km at the start of a trip. and 2400 kilometer at the end of the trip. If the trip took 8 hours, calculate the average speed of a car in a kilometer per hour and meter per second. Okay. So here you need to understand what is this odometer. Okay. Odometer. So this is the device. Okay. Device, or else you can call it as an instrument. Okay. Device or instrument. Instrument used to measure. Okay. Used to measure of a distance or length. Okay. Odometer. Odometer generally you'll be seeing on the in front of steering. Okay. Or else in a bike you'll be seeing that kind of round. Okay. So when you see the vehicles, you see how fast the body is moving, also how much distance it has covered. Okay. So that entire display, we call it as a odometer. In that, the speed of the vehicle as well as the distance covered, it will be showing. So we will be considering only odometer. That is the instrument used to measure the distance or length traveled by that body. Got it? Now, the question says, first, the odometer of a car reads a 2000 kilometer at the start of the trip, means initially. Okay, initially. And 2400 kilometer at the end of a trip, means let's try to understand, visualize it. Okay, visualize it. Visualize it. Okay, so it will be better in understanding if we visualize that. Okay, let's consider this is a vehicle. Okay, yes, and these are the wheels, and this is the car. Motion. Okay, motion. So initial position, how much? It is the 2000 kilometer. It is the 2000 kilometer. Okay, and it is the initial point, starting point. Okay, starting point. Starting point, and ending point is here. Ending point. Ending point. So ending point, this car has reached this point. Okay, so let's consider. Array. No, it is not working out. The car is here. Array, what happened? Finally, the body is here. Okay. So what is the distance traveled? That is the 2400 kilometer. Okay, 2400 kilometer. What is the time taken by this? It is 8 hours. 8 hours. Okay. And what is the distance traveled from here to here? If I take the difference of these two, you will be getting distance. Okay. It is the distance traveled, that is a 400 kilometer. Okay, 400 kilometers. Sir, how do you get to know this is the 400 kilometer? Because initially it is already 2000 kilometer and finally it has reached 2400 kilometer. The total distance between these 2 points, what is the distance between these 2 points? Means the difference of the points. So that is the 2400 minus the 2000. How much you will get? That is the 400 kilometers only. Okay, and here they have asked average speed. Okay, here they've asked average speed in a kilometer as well as a meter per second. Okay, so let's calculate in terms of first kilometer per hour only. So first one, average speed. Here no need to specify the direction, and by the formula it is the total distance divided by total time. It is the total distance divided by total time. Okay, total distance and total time. So here total distance, how much? It is the 400 kilometer. Okay, so 400 kilometer divided by time, it is a 8 hours. Okay, so here you can see, so 8 ones are 8 fives are and 50. So average speed, that is a 50 kilometer per hour. Okay, so this is average speed, okay. So this is in terms of a kilometer per hour, but this is in terms of a kilometer per hour, but here they've asked in terms of a meter per second also. So for that, what I will do, so first try to understand 1 kilometer per hour. Okay, 1 kilometer per hour. This one can be written as 1 kilometer, okay, per hour, or else this can be written as 1 kilometer per hour. So all these are same. Okay, so let's try to understand this 1 kilometer per hour. So this 1 kilometer per hour can be written as 1 kilometer divided by 1 hour. As we know that a speed is given by distance divided by time, right? Distance divided by time. Distance in kilometer and the time is in hours. So we need to express this kilometer per hour in terms of a meter per second, where meter per second is the SI unit of a speed or velocity, right? So we need to convert it. Okay, so 1 kilometer means how much? 1 kilometer is the length, but how many meters? That is, a 1 kilo means 1000 meters. Okay, and 1 hour means how many minutes? First of all, in 1 hour we know that it is the 60 minutes. Okay, minutes are the not the SI unit of a time. What is the SI unit of a time? It is the second. Therefore, we need to write a 60 as it is. 1 minute, can I write this one as 60 as a 60 into 1 minute, and a 60 into 1 meter can be written as a 60 seconds, right? And a 60 seconds into 60 seconds, that is a 3600 seconds, right? So that means in SI unit, 1 hour is equals to 3600. 1 kilometer is equals to 1000 meter. So substitute the values here. Okay, so 1 kilometer is nothing but 1000 meter divided by 1 hour is equals to 3000 second. Okay, now here you can see 2 zeros and 2 zeros get cancelled, and you can divide this one with a 2 5s are and 2 1s are 2, 2 8s are 16. So finally you can write 1 kilometer per hour, that is a 1 hour, that is 5 divided by 18 meter per second. So this can be, in a simplest way, you can write 1 kilometer, okay, so per hour, that is equals to 5 divided by 18 meter per second. Okay, so that means bigger unit to smaller unit. Okay, this is the bigger unit to smaller unit. What if you write smaller unit to bigger unit? 1 meter per second can be written, cross multiply this one. So 18 divided by 5 into kilometer per hour. Okay, so here bigger unit to smaller unit. Okay, this is bigger unit to smaller unit, here smaller unit to bigger unit. Okay, and according to the given question, okay, according to the given question, already we know that what is the value? That is the 50 kilometer per hour, right? So 50 kilometer per hour average speed, average speed, average speed, average speed, that is equals to 50 kilometer per hour, right? Per hour. And we know that 1 kilometer per hour is equals to 5 divided by 18 meter per second. So this one can be written as 50 as it is 1 kilometer per hour. We can write in this way. And 50 into 1 kilometer means 5 divided by 18 meter per second. Okay, meter per second. And use the calculator, or else if you are good at mathematics, you can do it. Okay, without calculator also. So 50 divided by 18. So how much it is? 2.77 into 5. So that is 13 point average speed. Average speed, that equals to 13.8889. So round it up to 89 meter per second. Okay, so this is meter per second. So this is in terms of kilometer per hour. Okay, so that can be written as, you see, 400 divided by 8 hours. That is a 50 kilometer per hour. Okay, got it? Or else another method you can follow. What is that method? So basic method, that is the total distance divided by total time. Okay, total distance divided by total time. So average speed average speed, method 2, average speed, that equals to total distance. How much it is? 400 kilometer. Okay, 400 kilometer. So 400 kilometer divided by 8 hours. So 400 into 1000 meter. Why? 1 kilometer is equals to 1000 meter. And 8 into 1 hour is equals to 3600 seconds. Okay. Use the calculator. You see. So 400 into 1000. Okay. So it is the 400, yeah. 4 followed by 5 zeros. Okay. 4 followed by 5 zeros divided by, it is a meter, and 8 into 36. 8 into 36, that is the 288 into followed by 2 zeros seconds. Okay. Now, final calculation, that is the 4 followed by 5 zeros divided by 288 double zeros. 13.13, here I'll write 13.89 meter per second. See, both the answers are correct. You can convert directly that 50 kilometer per hour to save the time. Okay, right. So this is all about, velocity, speed, distance, displacement, rest, and motion. Okay. Now let's move on to the next topic. Here we have one more question. Okay. The question is, Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Okay. So let's consider this is a swimming pool. Okay. So these are the ends. Okay. And here swimming pool, let's consider. Okay. Swimming pool. So this is the water. Okay. This is the water. Okay. And what is the distance or else length of the pool? That is the 90 meter. 90 meter from here to here. Okay. So according to the question, first Usha has traveled. Okay. Has traveled from one end to another. That is the 90 meter. And back. That is also 90 meter. Okay. So here the question is, find the average speed. To find out average speed, first we need to know, first case I'll consider. Okay. First case, total distance. Okay. Total distance. How much? 90 plus 90. Right? 180. So 180 meters. One way it is the 90 meter. Another way, this is also 90 meter. 90 plus 90, 180 meter. And total time. That equals to 1 minute. 1 minute. Convert that into SI unit. If the quantities has given in a different unit, system of units, first you need to convert that into SI unit. Okay, SI system unit. Now, 1 minute is equals to 60 seconds. Okay. Now, average speed. And we know that average speed is nothing but total distance. How much it is? 180 meter divided by 60 seconds. Okay. And here you can see 1010 get cancelled and 3. 6 3s are 18. So 3 meter per second. Okay. Average speed, it is done. And the next case, what they're asking? So average speed, it is done, and average velocity of the Usha. So second point or second case, what is the total displacement? Total displacement or a displacement. Okay. Total displacement. See, Usha has started from this position. Okay. Has reached this point. For example, this is A and this is B point. Has reached B and again come back to the same position, that is A. Right. B to A. So 90 meter one direction, 90 meter another direction. So that means initial and final position is same, right? Initial and final position is same. That means initial and final position is same. Means what is the distance, that shortest distance between initial and final position? That is the 0. Displacement is 0 meter. Why? The initial and final position is same. For example, let's consider this is my initial position. Okay, I have traveled 90 meter and come back to the same place by traveling 90 meter distance in a opposite direction. Means initially my position it is this one. Means let's say point A, and I have traveled 90 meter in this direction and changed my direction and came to the same position. That means initial and final position is same, therefore displacement is 0. And total time already we know that is the 1 meter. Okay, and here average velocity, here I'll write AVG. Average velocity is 0 divided by 60 seconds. That is equals to 0 meter per second. This is all about, average speed and average velocity. Got it? So by this, we can conclude that, speed, speed cannot be 0. Okay, speed cannot be 0. But velocity can be 0 if a displacement is 0. Right? Is it clear? Simple task. Now, let's move to the next topic, that is the rate of change of velocity. So velocity, already we know that it is the shortest distance between initial and final position, right? So, and also we know that velocity is nothing but speed plus direction, right? Speed plus direction. When you say change in velocity, okay, change in velocity, what are the possibilities? When you say change in velocity, what is the possibility? First, change in speed, or change in direction. Okay, change in direction, or both means speed and direction. Then we can say there is a change in a velocity. Okay, so if there is a change in a position, we had a physical quantity, that is a distance or displacement. When we have considered a motion, there are two terms. One is the uniform motion, another one is non-uniform motion. When we considered distance and time relation, we had a new physical quantity, that is the speed. When we have considered distance along with the direction and time, that is nothing but displacement and time, we had a new physical quantity, that is the velocity. Here we have a change in a velocity due to maybe magnitude, nothing but a speed, or a direction, or by the both. Then what is the new physical quantity? So that new physical quantity, we are calling it as a acceleration of the body. Okay, when there is a change in velocity, maybe due to magnitude or direction or both, then we can call that physical quantity as a acceleration of the body. Okay, right. So here you can see rate of a change of velocity. Okay, rate of change velocity. Here is the definition. First, definition wise, when the motion is non-uniform means the body do not cover equal distance in an equal interval of time. Then speed varies. Then direction. If the speed varies, velocity varies. If a speed is a constant, means the body is covering equal distance in an equal interval of time, speed is constant. But the direction, if the direction of a body changes, then velocity changes, or else both can be changed. That is a reality. Okay, there can be expected all these possibilities, maybe change in the magnitude, maybe change in the direction, or else both. Okay, now here we have, when the motion is non-uniform, the object is said to have an acceleration. Sir, what if we consider uniform motion? Uniform motion means the body has covering equal distance in an equal interval of time in a particular direction. Means the direction is same, the distance covering is equal in an equal interval of time. There is no change in velocity. Then There is no change in velocity means there is no acceleration. What if I consider non-uniform velocity? Sorry, non-uniform motion. Non-uniform motion means the body may cover equal distances in an equal interval of time, but a change in direction. Then we can call it as a change in velocity. Or else the body covers equal distances in an equal interval of time, but a change in direction. One possibility. Or else the body moving with the same direction, but a change in a magnitude. Means it is not covering equal distances in an equal interval of time. Then you can call there is a change in a velocity. Got it? Now, the change in velocity of an object with a time interval is called acceleration. What does that mean? So let's consider one body, okay? One body and moving with initial velocity u. Initial velocity u. After some time, okay? After some time, after some time, after some time, the velocity of the body v means this is the initial velocity and this is the final velocity, means the change in a velocity. For example, I'll consider example also, okay? Don't worry. So this is the a road or else a floor or else a ground, okay? So in a time t, from here to here, the velocity has changed from initial velocity u to final velocity v. Then how does acceleration can be presented? Acceleration A, change in a velocity, okay? Change in velocity. Change in velocity divided by total time. Total time or else time, just a time, okay? Let's consider time. So here you can write change in velocity means final velocity minus initial velocity divided by time, okay? Divided time. And finally, you can express acceleration as v minus u divided by t. Okay. V minus u divided by t. And here, SI unit of this acceleration. What is the SI unit of a velocity? That is the meter per second, right? So here I can write it is a meter per second divided by time is also second, measured in a second. Therefore, it can be written as meter per second square. Why? The second is also moving up. Therefore, second square. Okay, meter per second. So here SI unit meter per second square. Second square. Meter per second square. In short, meter per second square. Okay, and the quantity, as it is depends on a velocity. Velocity is a vector quantity. Therefore, acceleration is also vector quantity. Sir, why it is a vector quantity? Your question is why it is a vector quantity? Because it depends on a change in velocity. Velocity, nothing but a velocity. Okay. So time is a scalar quantity. But as acceleration is a depends on a velocity, velocity is a vector quantity because it depends on a direction. Right? So hence this acceleration is also vector quantity. Okay. Now here I'll write the meaning of the symbols. Okay. U is initial velocity. Initial velocity. And the next one, V, that is final velocity. That is final velocity. And T, you know that is the time. Got it? So this is the definition and this is the SI unit and this is the quantity, vector quantity. Okay. Now let's move on to the next concept, that is questioning part. Okay. Exercise number 4, that is the 7.4. 7.4. Why 7.4? Because it is a chapter number 7. In your science textbook, this is the chapter number 7. In physics, this is the chapter number 1. Okay. Right. The question, read the question. Starting from a stationary position means rest. Rest means initial velocity becomes a 0. Right. Initial velocity becomes a 0. Rahul pedals is a bicycle. Okay. Or else a bicycle to attain a velocity of 6 meters per second in 30 seconds. Okay. So they have given first case, this is the final velocity for the first case till here. Okay, starting from this is the first case. Starting from stationary position, that is initial velocity 0, Rahul pedals the bicycle to attain velocity of 6 meter per second in 30 seconds. Then he applies the brakes. What happens to the motion? Motion will be there, but what happens to the speed? Reduces. That means the magnitude is changed. So what happens to the speed? Reduces, means it decreases. So it is moving 6 meter per second. Now brakes such that the velocity of the bicycle comes down to the 4 meter per second. This is the second case. Final velocity is a 4 meter per second. In the next 5 seconds, we need to calculate acceleration of a bicycle in both the cases. Okay, so let's consider case 1. What is the case 1? The body has started from rest to final velocity. Okay, rest to the body, or else the bicycle from the rest means 0 meter per second, and the final velocity, how much it is? 6 meter per second. 6 meter per second, and the time, that is the 30 seconds. Okay, 30 seconds. And here acceleration, which is given by final velocity minus the initial velocity divided by time. So final velocity, it is 6 meter per second, and initial velocity is 0 meter per second, and the time it is given by 30. So that means here you can write that is 6 divided by 30. So 6 ones are 6. 6 5s are, right? Yeah. So 6 ones are 6 5s are. So that is the 1 by 5. Here you can write 0.2. So acceleration will be 0.2 meter per second square. This is the first case. Okay. Now let's move on to the second case. What is that the second case, sir? Case 2. Okay, case 2. So already it is a moving with. From here you have to consider. It is the initial velocity for the second case. Okay, initial velocity. Okay, that is final initial velocity is the initial velocity is the final velocity of the first case. That is 6 meter per second. And what happened? Then he applies the brake such that the velocity of the bicycle comes down to 4 meter per second. That is the final velocity, 4 meter per second. In a time, what is the time? 5 seconds. That is the 5 seconds. And acceleration, what is the acceleration? Acceleration, it is given by v minus u divided by t. What is the v value? 4 minus u value, that is the 6 divided by 5. So that is again 2 divided by minus 2 divided by 5. Okay. And here you can consider minus 2.2 divided by 5 means, so 0.4, right? So here you can see, so 5, 2, it is not divisible. Therefore, take a point and add 0. 5 4s are 20, right? So 0. So here you can consider 0.4 meter per second. Okay. So here you can observe, okay. Sir, in this case, A is equals to 0.2 meter per second square. But in this case, A is equals to minus 0.4 meter per second square. What does that negative sign indicates? Okay. So A value can be positive or negative. Okay. Positive or negative. So if A, if it is a positive, that means velocity and acceleration in same direction. Okay. Velocity and acceleration both are in same direction. If A is negative, what does it mean? Velocity and acceleration are in opposite direction. opposite direction. Clear? Okay. Now, what happens to the, acceleration and velocity are in the same direction? Velocity increases, or else speed increases. Velocity and acceleration are in opposite direction means the velocity or speed decreases. Okay. Speed up and speed down. If A is positive means speed up. Speed is increasing. If A is negative means speed is decreasing. That's all. Okay. Now, let's move on to the next concept, that is the graphical representation of a motion. So what is the necessity of this graphical representation? Line, number system, or do you have learned in a mathematics, linear equations and all, right? So let's take an example of a cricket. Maybe it is the ODI, one day international cricket, or else a T20. So you may have seen in a graphical presentation of a number of balls in a over with respect to number of runs scored in that particular over. Or else in another situation, required run rate, okay, and number of left out balls. The comparison, okay, which makes us understand easily what is the situation of a match. What is the result of the match going to be? So graphical representation gives, easiest understanding of the different units, or else different events you can see. Okay. So easiest understanding of a different events, we have to use graphical presentation. Okay. In the same way, in a motion, means the parameters of a motion, maybe a distance, a displacement, maybe velocity, speed, maybe acceleration, and opposite of that, retardation. Okay. So all these quantities, to understand easily in a different events, we are using graphical representation of those quantities. Okay. So let's try to understand what is the speciality of this graphical presentation. The first one, graphs provide a convenient method to represent basic information about the variety of events. This is the main reason we are using graphs to, okay, graphical representation of a motion. Okay. The first example you can consider. First example. Okay. First example. In the telecast of a one-day cricket match, vertical bar graph show the run rate of a team in each over. As we have studied in a mathematics, straight line graph helps in solving linear equations having two variables, x and y. Okay. Variables in our mathematics generally be considered as a x and y. Okay. And three variables means x, y, z. Okay. So linear equation. Okay. Already you know that. Now, next one, to describe motion of an object, we can use line graphs. Okay, line graphs. Maybe it is a straight or else it is a curve. But we have to use a straight lines only because our topic is motion in a straight line. Getting my point? Okay. Now, line graph show dependence of one physical quantity such as the distance or velocity, or another quantity such as time. Okay. So while representing a quantities graphically, okay, we have to use independent quantities along x-axis and dependent quantities along y-axis. Okay, independent quantities along x-axis and dependent quantities along y-axis. You can ask, sir, what and why? Okay, why we need to express independent quantities along x-axis and dependent quantities along y-axis? It is our convenient. Okay, that's how we used to. Got it? Now, and for easy understanding, we are using convenient methods. That is the one of the convenient methods we are using. That is along x-axis, that is independent quantity, and along y-axis, it is a dependent quantity. Right. The first one, let's see, distance time graph. Distance time graph. Okay, distance time graph. The change in the position of an object with the time can be represented on the distance and time graph adopting convenient scale of a choice. Okay, convenient scale of a choice means it is up to unit whatever you want. Okay, so here Distance means we know that it is the total length of the path. Okay. When the body changes its position with respect to time, then the body is in a motion. That motion of the body is represented with a, distance and time graph. Okay. So the motion can be uniform motion or else non-uniform motion or else the body is at rest. Okay. Let's consider different situation, okay, in a better way. The first one you see in this graph, time is taken along the x-axis and distance is taken along y-axis. The distance time graph can be employed under the various conditions where objects move with a uniform speed, non-uniform speed remains at rest. That's what I said in the beginning. Maybe uniform motion or non-uniform motion or else the body is at rest. Okay. Here they have used uniform speed, non-uniform speed or else a rest. Getting my point? Okay. Now, let's move on to the first condition. For an object moving with a uniform speed. Uniform speed means already we know that. Uniform motion. Let's consider uniform motion mean only. Okay. So uniform motion is nothing but if the object is covering equal distances in equal interval of time in a particular direction, then we can call it as a uniform motion. So in place of a motion, if we use a speed, that indicates equal distance covered in an equal interval of time by the body in entire journey is called uniform speed. Okay. So example, you can see the table. So along x-axis, what we are considering? Time in a t. And the next one, distance along y-axis. So this is in terms of a meter and this is in terms of a seconds. Okay. Time it is in terms of a seconds. Time in terms of a seconds and the distance in terms of a meter. Okay. So let's try to understand. This is the origin. Okay. Origin. So let's consider time. This is 1 second and this is 2 second and this is 3 second and this is a 4. This is 5 and this is 6 and so on. Okay. Distance, let me consider. This is a 2 meter and this is a 4 meter and this is a 6 meter and this is 8 meter and this is the 10 meter. Okay. Right. This is our convenient scale. Okay. I have considered convenient scale of this distance and this is the time. You can consider time as a 2 second, 4 second, 6 second and 8 second and so on. It is up to you. Okay. And distance can be 1 meter, 2 meter, 3 meter, 4 meter and 5 meter and so on. Okay. It is up to you. Convenient readings. Now, let's consider at a 0 second, what is the distance? 0 meter. At a 0 second, distance is 0 meter. Yes, first point it is clear. Okay, here it is here. Next one, in 1 minute, what is the distance traveled? That is the position, nothing but 2 meter. So, here you see, in 1 meter, okay, in 1 meter, in 1 second, the distance is traveled 2 meters. So this is the second point. Yes, this is the second point. Next, in a 2 seconds, what is the distance? 4 meter. In a 2 seconds, the distance is a 4 seconds. Sorry, 4 meter. In a 2 second, the distance is a 4 meter. Okay. Next one, 3 second, the distance is 6 meter. In 3 second, distance is 6 meter. 6 meters. Okay. And the next one, 4 second means a 4th second, the distance is 8 meter. Okay. Right. And distance is 8 meter. 8 meter. Clear? Now, what we have to do? Just to join the lines. That's all. Just to join the lines. Just to join the lines. Okay. Just to join the lines. Okay. So this is the straight line, white color. Okay. White color straight line indicates the graphical presentation of object moving with a uniform speed. And from this graph, okay, from this graph, we can calculate the speed of the body. How, sir? Speed of the body can be calculated, okay? Speed of the body can be calculated by using slope of this graph. What is that? A slope. Slope in a mathematics we may have learned change in y-axis divided by change in x-axis. Okay, change in y-axis divided by change in x-axis. In the same way, what is that? A change in y-axis divided by change in x-axis. For example, okay, at a particular instant of a time, let's consider, it's up to you, okay, you can consider any time interval, okay. So I want to calculate what is the speed of the object at a 3 second. Okay, so what is the speed at this point? Okay, so what do you have to do? Change in a y-axis means, change in y-axis means, this is, let me consider, this is the final y2, this is the y2, and initial point is this one. With respect to origin, we have to consider 1. Okay, or else any between 2 points also you can consider. Okay, okay, let's consider the speed between 2 second and 3 second. Okay, 3 second, 2 second and 3 second. Let's consider this is array. This is y1. Okay, this is y1. Change in a y-axis means y2 minus y1 divided by change in x-axis along x-axis, 2 seconds and 3 seconds. Okay, now, so what do you have to do? x2 minus x1. That means this is x2 and this is x1. What is the value of this y2 minus y1? y2, it is the 6, y1, that is the 4, divided by x2, that is the 3, minus x2, 3, x1, that is the 2. So 4 minus 4 divided by 3 minus 2, that is a 1. So here, okay, this is the 2, right? 6 minus 4, that is the 2, divided by 3 minus 2, that is the 1. So speed is nothing but 2 meter per second. This is how you need to calculate the speed of the body at any interval of a time. Okay, so here you can consider slope nothing but it is a change in y-axis divided by change in x-axis. Okay, so this is where we have calculated speed, right? So here you can consider this is change in x-axis and this is change in y-axis. So this is looks like a triangle. We can consider change in y-axis, this one, change in y-axis, and this is change in x-axis. That's all. And area under this distance versus time graph does not have any meaning. Does not have any meaning. Got it? Now let's move on to the next case. Okay, so the first case, it is for uniform speed. Next case, let's see non-uniform speed. Okay, so same way, this is the distance. This is the distance in a meter, and this is the time in the seconds. Okay, now, so let's consider, this is 0 point, that is the origin, and this is 1 second, and this is 2 second, and this is 3 second, and this is 4 second, and this is 5 second, and this is 6 second, and this is 7th second. And displacement, you can see up to 16 meters. Okay, so let's consider 2 meter, 4 meter, 6 meter, 8 meter, 10 meter, 12 meter, and 14, and the last one 16. Okay, so these are the distance of the body. Now at a 0 second, okay, at a 0 second, what is the distance? At a 0 second, distance is 0 meter. This one, this point. Okay, now 1 second, 1 meter. 1 meter means in between. 1 second, 1 meter. 1 second, 1 meter. This is 1 second, and this is 1 meter. Okay, fine. So this is the second point. In a 2 seconds, distance is a 4 meter. In 2 seconds, distance is 4 meter. This is 4 meter. And at 3 seconds, distance is 9 meter. 9 meter. Half of that. Okay, between 8 and 10. Okay, now, and a 4th second, 16. Distance is a 16. 4th second, 16. Here. Okay, now here it is. What do we have to do now? We have to join all the points. Okay, so this is not a straight line, but instead of that, it is the curved line. So same way, slope gives you at any point, okay, between any point, slope of distance time graph, okay, distance time graph gives you speed of the object. So if it is a curved line, distance versus time graph, it is a curved line that indicates a non-uniform speed. Okay, now let's move on to the next concept and the next case, that is the rest. Okay, so let's consider this is the distance in a meter and it is a time in a seconds. Okay, so let's consider markings. This is the origin, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, and 7 second. And distance, let me consider maximum distance, that is the 4. Therefore, 1, 2, 3, 4, and 5 meter. Okay. Now, according to the data, at a 0 second, what is the distance at a 0 second? So 0 second means, take this one, 0 second at a 4 meter. Yes, the first point is here. Okay, and 1 second, 4 meter again, 1 second, 4 meter again. Okay, so this is second point, and second 2 second, 4 meter again. Okay, so this is the 4 meter, and third second, this is again a 4 meter, and fourth second, again it is the 4 meter. Now what you need to do is just join the lines. Okay, just join the lines. So here you got a straight line parallel to the time axis. Means this one body at rest parallel to the time axis. You see, the time is keep on changing, but what happens to the distance? The distances remain same. 4 meter, 4 meter, 4 meter, 4 meter, and 4 meter. The distance is not changing. Means the position of the body is not changing from the origin, right? From the origin, you can consider 4 meter, 4 meter, 4 meter, 4 meter. With respect to reference point, that is the 0. The position of the body, that is at 4 meter, it is not changing with respect to time. Time is changing, but the distances remain same. So the body is at rest. Got it? Now, let's move on to the next topic. That is the velocity time graph. Let's see what is this velocity time graph indicates. Okay. The variation in velocity with a time for an object moving in a straight line can be represented by velocity time graph. Okay. Velocity time graph. Similarly, like, distance versus time graph only, where we have considered distance versus time. The ratio of a distance and time, what you'll get? That is the speed only. So slope, that is also speed. Okay. So that's how velocity and a time graph gives you the slope of a VT graph. That is the velocity time graph gives you acceleration of the body. Okay. Right. So in the same way, in this graph, time is represented along x-axis and the velocity along y-axis. This is the y-axis. Okay. This is y-axis. Velocity time graph can be employed under various conditions where objects move with a uniform velocity, uniformly increasing velocity, that is nothing but uniformly accelerated motion, and the last one, uniformly decreasing velocity. Let's see 3 cases they have given. Let's see one by one. Okay, so here along y-axis they have given velocity, okay, and along x-axis time only in seconds, and this one meter per second. Okay, now, so the first case, uniform velocity. Uniform means the same. And here velocity divided by, okay, velocity divided by time. What you'll get? Acceleration. Okay, velocity divided by time, you'll get acceleration. So from the graph, how do you calculate acceleration? By slope. Like we have found that the first case, okay, this one. So distance by time, what you'll get? Distance by time. What do you get? Speed, right? Speed or velocity. As it is the one-dimensional motion, the direction do not change, means speed equals to time only. Speed equals to velocity only. Okay. So in the same way, let's try to figure it out. So what are the conditions and what we need to do with? Okay. So first case, you can check velocity 6 meter per second, 6 meter per second, 6 meter per second during the time interval 0, 1, 2, 3, 4. Okay. So let's consider the first 0 and 1 second, 2 second, 3 second, and 4 second, and 5 second, and a 6 second, and a 7th second. And here 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second, 5 meter per second, 6 meter per second. Okay. At a 0 second, okay, what is the velocity? You can see this one. Let's reduce the thickness. Yes. 0 second, the velocity is 6 meter per second. And the first point is here. And the 1 minute, again 6 meter per second. Not 1 minute, 1 second, okay. 1 second, that is the meter per second, that is 6 meter per second velocity. And for the rest of the time also, it is the same, that is 6 meter per second, 6 meter per second, 6 meter per second. Here you can see, of that what you have to do is join all the lines. When you join all the lines, you'll get a parallel, okay, parallel line, okay, parallel line with respect to time axis, okay, parallel to the time axis. So that means uniform velocity, uniform velocity, uniform velocity, that is equals to acceleration is 0. Means the velocity is not changing. According to the definition, acceleration is nothing but change in velocity divided by time. But here you can see there is no change in velocity, hence acceleration is 0. Okay, acceleration is 0. Okay, now let's move on to the next case. Uniformly increasing velocity. Uniformly increasing velocity. Okay, this is velocity in a meter per second, and this is time in a second. Okay, now the first, let's consider origin 1 second and 2 second, 3 second, 4 second, 5 second, 6 second, and 7 second. And the velocity you can see up to 40 meter per second, means I'll consider this as a 10 meter per second, and this is 20 meter per second, this is 30 meter per second, and this is 40 meter per second. Okay, now so first one, let's consider at a 0 second, what is the velocity? First 0 second, 0 meter per second. Okay, first point, it is clear. Second point, that is 1 second, velocity is 10 meter per second. Velocity is 10 meter per second. So this is 10 meter per second. So this is the point. Okay, now in 2 second, 20 meter per second. In 2 second, 20 meter per second. And 3 seconds, okay, 3 seconds, and 30 meter per second. 30 meter per second. Okay, and a 4th second. Okay, that is the 4th second. Yes. Okay, now what we have to do? Join all the points. Join all the points. Yes, joined. Okay, joined. So this line indicates the presentation of velocity and time of a particular body during this 4 second. Okay, now by this graph, what we can conclude? Okay, slope of VT graph. VT graph means velocity time graph, gives you acceleration. Acceleration. How to find out the slope? Slope, it is given by change in y-axis divided by change in x-axis. Or else you can write y2 minus y1 divided by x2 minus x1. we have solved a few, one question with respect to distance versus time, right? So this is how you can do it, okay? This is how you can do it. Now, let's move on to the last question. Before that, slope of VT graph gives you acceleration of the body and area under VT. This is not so important for your 9th class, but for your extra information, for extra information, okay, for extra information, area under VT graph, okay, area under VT graph gives you, displacement, okay, or distance, okay. Now that's all for the second case, and let's move on to the last case, that is the decreasing velocity. Same way, this is velocity in a meter per second, and this is the time. This is time in a second, okay. Now let's find out the origin and the time. 1 second, 2 second, 3 second, 4 second, 5 second, and 6 second. And here velocity can see up to 40, means this is 10 meter per second, and this is 20 meter per second, and this is 30 meter per second, and this is 40 meter per second, and this is 50 meter per second, okay. Now let's try to figure out with respect to time as well as the velocity. So at a 0 second, the velocity of the particle or body, it is a 40 meter per second, okay. At a 0 second, 40 meter per second, okay. At 0 second, the velocity of the particle or body, it is a 40 meter per second. The next one, 1 second, it is the 30. In 1 second, it is the 30. In 1 second, it is the 30. And in 2 seconds, it is the 20. You can see the data, okay. Then, in next second, it is the 10. Okay. Next second, that is the 10. And finally, 4th second, it is a 0. And what you need to do is just join these lines. Okay. Just join these lines. Okay. So here, there is no proper scaling. That is the reason there is a small difference is occurring here and here also. Got it? So after joining this one, you can find out a slope. Slope gives you acceleration. Then area under VT graph gives you displacement or distance. Okay. Now let's move on to the next concept, that is equations of motion. Okay. These are very, very important for class 9th students. The derivation part is not required. Okay. Derivation part is not required. And these derivations you will be learning in a class 11th. Okay. You will be learning in the class 11th. Just you need to remember the equations of a motion. And these equations of motion is completely related or used when the uniform acceleration of the particle is there. Means so for a uniform accelerated motion, we can use these equations of motion. What if it is the accelerated motion? These equations of motion is not valid. Okay, directly you can go ahead with a generalized formulas like a definition wise we defined, right? So that's how we can calculate. Okay, now, so what is the use of these equations of motion? First thing. So firstly, this equation means there are 3 equations of motion, and these equations of motion for only uniformly accelerated motion of a particles or objects or bodies. Okay. Now, here you can see when an object moves along a straight line with a uniform acceleration. This is related to uniform acceleration. It is impossible to relate. Okay, it is a possible to relate. It is not impossible. It is a possible to relate. It's a velocity, acceleration during the motion, and the distance covered by it in a certain time interval by a set of equations known as equations of motions. Equations of motion. Then, for convenience, a set of 3 such equations are given below. Here not given, but I am going to write down. Okay, so these are equations of motion. Okay, the first equations of motion. Okay, the first one, V is equals to U plus AT. Okay, second one. Okay, second equation of motion, that is V, or else a displacement one you can write, S is equals to UT plus of AT square. And third one, okay, third equation of motion, that is V square is equals to U square plus 2AS. Okay, this is the first equation of motion, and then this is the second equation of motion, and then third equation motion. Okay, now when we have to use these equations of motion, so whenever you do not have displacement, okay, independent of a displacement in the question, okay, in the question if you don't see displacement, then you can go ahead with the first equation, independent of displacement. Independent of displacement. Independent of a displacement. Second one, that is, in here you cannot see V, right? V means final velocity. Independent of final velocity. Final velocity. And next one, here you are not able to see time, right? It is independent of a time. Independent of time. Independent of time. Okay, so one more time, let's try to understand the symbols that we are using in the equations. Okay, first one, V means the final velocity, U means initial velocity, A means acceleration, T means the time of the journey, and S means displacement. Okay, here I'll write S means displacement, or else you will think that it is a speed. Okay, it is a displacement. Okay, remaining as usual. Okay, right? Fine. Let's move on to the next concept, that is questioning part. A train starting from rest. Rest means what happens to the initial velocity? Initial velocity will be 0. Attains a velocity of 72 km per hour in 5 minutes. So here 72 km per hour. That means a final velocity. This is the final velocity. In 5 minutes, that is the T, time they have given. Assuming that the acceleration is uniform. That means acceleration is uniform. Okay, fine. Fine. Acceleration, second one, the distance traveled by the train. As it is a one-dimensional motion, or you can say as it is a motion in a straight line. So in a motion in a straight line, distance and displacement are same. Therefore, speed and velocity is also same. Okay, now first case, let's see. So first case for acceleration. Okay, the acceleration, for acceleration, or the acceleration A. Okay, now so first we need to write down given data. U is equals to 0, V is equals to 72 km per hour, but it is not a SI unit. Therefore, we need to convert SI unit to CGS. Kilometer per hour to SI unit. V is equals to 72 kilometer per hour to meter per second. Bigger unit to smaller unit. What we have to do? 5 divided by 18 meter per second. Sir, how do we get this 5 divided by 18? Already conversions we have learned. Where? Let's see. Conversions. Yes. Conversions we have learned. Bigger unit to smaller unit. 5 divided by 18. If you want to convert that a smaller unit to bigger unit, you can use 1 meter per second is equals to 18 divided by 5 km per hour. Okay. So that's how the formulas works. Okay. Now, given data. Yes. So here you can see 18. Yes. So 72 divided by 18. Arre, 72 divided by 18. How much it is? The 4. So 4 into 5, that is 20 meter per second. Okay. And the next one, what they have given? Time. Time they have given. How much? 5 minutes. 5 minutes. And 5 minutes, it is not a SI unit, therefore convert that. So 5 into 1 minute is equals to 60 seconds. That means 300 seconds. Okay. So now here you can see initial velocity, final velocity, and the time. It is independent of a displacement. Therefore, which equation of motion we have to use to find out acceleration? So for acceleration, independent of displacement, which equation of motion we have to use? Independent of displacement. That is the first one. V is equals to u plus at. And you need a. Therefore, rearrange this equation. V and this u, transfer it to the left hand side. What happens? This plus u becomes a minus u. That equals to at. And just I'm writing this one as at is equals to v minus u, rearranging, just rearranging the equation. V minus u divided by t. Okay, substitute the values. V, that is a 20 meter per second, and u, that is a 0 meter per second. Therefore, divided by 300. Okay, 300 seconds. Okay, now a equals to, so 20 divided by 300, that is 0.067 meter per second square. Okay, 0.067 meter per second square. Now, next one, distance traveled by the train. Distance traveled by the train. Second part. Part 2. Second part. That is second one, distance. For a distance. Okay. So for a distance. So here you can use. Okay. For a distance means a displacement I'll consider. So which equation of motion you can use? Directly you can go ahead with third equation of motion. That is v square is equals to u square plus a 2as. Right? Now, substitute the values. V square, what is the V value? That is the 20 meter per second. That means 20 whole square. That equals to u square, that is the 0, right? 0 whole square plus 2 a. A value, already you know that. That is 0.067. 0.067 into displacement or distance. So 20 square, that is the 400 is equals to 0. 2 into, let's see. So 2 into 0.067, 0.134 into displacement. And S is equals to 400 divided by 0.134. Okay. And if you see that, so 400 divided by 0.134. 134. Yes. So 400 divided by 0.134. So that is 2985.07 meters. Okay. Or else you can write 2985 approximately meter, or S equals to, that is the distance is nothing but 2.98 kilometers. Okay. Anything is fine. Okay. Anything means this one or this one you can write down. Okay. Right. Let's move on to the next topic. Next question, that is 7.6. 7.6. A car accelerates uniformly from 18 kilometer per hour to 36 kilometer per hour. Means this is the initial velocity and this is the final velocity. And this is the time. Calculate acceleration, second one distance covered by the car. Okay, as it is. First, what you need to do. So let's consider this as a homework question. Okay, homework question. Previous one as it is. So here, first I'll give the data how to solve this one. Okay, so data. So initial velocity that is 18 kilometer per hour. Okay, so this can be written as 18 into 5 by 18 meter per second. Okay, and u equals to, so 18 get cancelled, so initial velocity that is a 5 meter per second. So initial velocity we got it, and a final velocity v equals to 36 kilometer per hour. So this is also can be convert into meter per second. So 36 into 5 divided by 18. So here 18.1, 18.2. So 10 meter per second. So V is equals to 10 meter per second. And time, let's consider a time. So time how much? It is the 5 seconds. Okay. Now, so what you need to do is, so first to find the acceleration. Already we know that formula, V minus U divided by T. Okay. This is the first formula. Then next one, as you need to find out distance, you can use this formula. V square is equals to U square plus 2AS. Rearrange this one. What you'll get? S is equals to V square minus U square divided by 2A. You can use this formula, or else you can use OR. Okay, or S is equals to UT plus of AT square. Okay, where do you get this A value? From here. Okay, from here you'll be getting. Got it? Now let's move on to the next concept. Again, next question. Yes. Question is, the brakes applied to a car produce an acceleration of a 6 meter per second. Okay, so this one is 6 meter per second, not a minus. So this is 6 meter per second square. Okay, in the opposite direction to the motion. Opposite direction means velocity and acceleration are opposite. If the car takes 2 seconds to stop after the application of a brakes, calculate the distance it travels during this time. Okay, and here a time they have given, and stop means final velocity is 0, right? This is final velocity becomes 0, and initial velocity we don't need, so calculate the displacement. Okay, distance or displacement. Okay, so here you need to understand the brakes applied to a car produces an acceleration of 6 meter per second. First data. So writing data. So acceleration, it is a 6 meter per second. In the opposite direction to the motion, means velocity opposite direction. Fine. If the car takes 2 seconds to stop, okay, V equals to 0. And after the application of the brakes, calculate the distance. Okay. So first you need to calculate, what is the initial velocity, right? Initial velocity. So first to calculate initial velocity. First case, initial velocity. Initial velocity. Initial velocity. So for that initial velocity, you can use it is the independent of displacement, right? Independent of displacement means V is equals to U plus AT. Okay. Now here you can find out 0. Final velocity is 0. Initial velocity plus acceleration how much? 6 into time, that is the 2. So that is 0 is equals to U. Okay. So U 0, that is equals to U. Acceleration opposite means negative sign, because motion is reduced, speed is reduced, negative sign. So plus, this is a minus sign. So plus into minus. So here I'll write minus 6 into 2. So minus 12. So therefore, U equals to 12 meter per second. So initial velocity I got to know. Okay, now next what we need to find out, distance. We can use any one of the formula. Okay, s is equals to ut plus half et square you can use. Okay, so for a distance, okay, s is equals to ut plus half at square. Okay, now s is equals to u, how much it is, the 12, time that is the 2 seconds, plus half acceleration that is the minus 6. Okay, because it is opposite in direction, and t square that is the 2 square. Okay, and displacement that is equals to 24, 12 into 2 24, plus into minus minus, and 2 ones are 2 threes are, so 3 into 4. Okay, and s is equals to 24 and this is a 12, so 12 meter distance it will travel, 12 meter. Okay, or else let's try out solve using third equation of motion. Okay, third equation of motion, that is v square u square plus 2as. Okay, so v square that is equals to 0 square, right? Because final velocity is 0. Yes, that equals to u square, that is the 12 square plus 2 minus 6 into displacement. So here 0, 144 minus 12, yes. Okay, yes is equals to 144 divided by 12. Okay, right. So here you can see 144 divided by 12, 144 divided by 12, so 12 meter, 12 meter. So two methods, in two methods you can solve the questions. Okay, in two methods you can solve the questions. This is 12 meter and this is the 12 meter, method 2. This is method 2. Whatever you need, you can go ahead with that. Okay, last concept of this motion chapter, that is uniform circular motion. Uniform means same. Okay, motion and uniform circular motion. So before moving on to the uniform circular motion, so let's try to understand velocity and direction. Okay, now so let's read out the content. Okay, the first one you see, when the velocity of an object changes, when we can expect the change in velocity, maybe magnitude. Okay, maybe magnitude or direction, or both, or both. Okay, we can consider change in velocity due to change in magnitude, or due to change in direction, or change in both. We say that object is accelerating. Okay, so whenever there is a change in velocity, then we can consider it as a acceleration of the body. Now the change in velocity could be due to change in its magnitude or the direction of the motion, or both. Okay, now can you think of an example when an object does not change its magnitude? Okay, in this particular situation, an object does not change its magnitude of the velocity, but only its direction. Means let's try to analyze the given examples. Okay, given examples. So first case, A case. Okay, so let's consider A, B, C and D. So let's start from A to B. Okay, the body has traveling A to B, the direction will be this side. Okay, that is towards east. From B to C, the direction will be downward, and C to D, direction will be west direction, and D to A, and here the direction. So how many times the change in a direction happened in this rectangular path, or else you can call it as a rectangular track. Okay, so you can observe A to B, one direction, east direction. Okay, this is east direction, and B to C, one more direction, two times. Okay, this is the first time, this is second time, and here third time, and this is the fourth time. So direction in this case, okay, direction 4 times changing. Okay, direction 4 times changing. And let's consider in this case A, B and C, and this is D, and this is E, and this is F. Okay. So A to B, one direction, B to C, one direction, C to D, one direction, D to E, one direction, E to F, one direction, and F to A direction, one direction. 1, 2, 3, 4, 5, 6. Direction is changed 6 times. Okay, direction has changed 6 times. So as I'm decreasing the length of the track, okay, I'm decreasing the length of the track, the direction keep on increasing. Change in direction keep on increasing. First it is the rectangle. Now this shape, okay, hexagonal. Now octagonal. Let's see what happens to the next one. So here again I'm decreasing the length, A, B, C, D, E, F and G. Okay, G, E, F, G, H. Okay, so first direction, second direction, third direction, fourth direction, fifth direction, sixth, seventh and eighth. Here a direction has changed. Okay, here direction has changed 8 times. Okay, and if I keep on decreasing the length of the path, okay, A to B, B to C, C to D, the length of the path as it is decreasing, the direction number of times it is increasing. Direction number of times means direction keep on changes. How many times it is going to change? That will increase. Okay, so finally the path is a circular. Okay, for every point, okay, every point the direction of a body or particle keep on changes. At every interval of a time the direction of a particle keep on changes. As the direction of a particle changes means, okay, next slide. In this particular case, okay, let me consider this is the first interval and this is second interval and this is third interval and this is the fourth interval. Okay, at every interval of a time, okay, let's consider this is radius of a circular track. Okay, this is the radius of a circular track and velocity in this way. So direction is changed. Okay, this is the velocity, this is along, you know, upward, and this is the velocity along left hand side means west direction. This is south direction. This is also velocity and this is also velocity. In this case, uniform circular motion means where speed of the particle remains the same but direction keep on changes at every interval of a time. Okay, so when object moves in a circular path uniform speed, it is called uniform circular motion. In this particular situation, we can conclude that speed is a constant. Speed is a constant. And what about velocity? Velocity changes. Velocity changes as direction changing. As the direction changes. As the direction changes. Okay, and if I want to calculate a velocity, okay, if I calculate a velocity, speed, okay, let me consider speed. If I want to calculate a speed, what is the formula? Distance divided by time taken. After one complete circle, okay, after one complete circle, after one complete round, what is the distance? That is the 2 pi r. Sir, how does it a 2 pi r? Because circumference of a circle, that is the total distance traveled and time. Okay, so this is the time. So this is how we can calculate speed. What about velocity? Velocity is magnitude is same but direction is keep on changes. Therefore this is the accelerated motion. This is accelerated motion. Accelerated motion. This is accelerated motion. Okay, right. And homework for today's lecture. Okay, that's all for the day, means chapter motion, and already we have completed entire chapter. Hopefully it is very useful for you. Okay, so what you need to do after completing the lecture? Revise today's lecture, highlight important concept or questions. Next one, note down your doubts in the notebook if any. Next class you can ask. Okay, in the next class you can ask. Okay, so that's all for today's session. So then we'll meet you in the next session. Till then, take care. Bye bye.